Hello, everybody. Welcome. My name is Simon Timpley from the International Food Safety and Quality Network. Welcome to Food Safety Fridays. Today's presenter is Maria Sandoval, from Lab Director from Trace Analytics, and today's subject is total oil, sources of contamination and how to test. So welcome back, Maria. Nice to see you. Good morning.
Great. Good morning, or I should say good afternoon for you guys.
It is. It's good afternoon from slightly overcast Manchester in the UK. And tell us where you're from, Maria. Remind us.
So I'm in Austin, Texas, and man, I can't tell you guys, it's 46 degrees Celsius over here right now. Um, so it's hot.
Well, we've just been talking about it, and sort of next week in the UK, it's going to get up into mid 30s Celsius, and we're all panicking. And then Maria's telling me it's mid 40s. So that's just insane. So tell us where you're from anyway. Let us know in the sidebar. So we've got Jalesa from Texas and uh, Guadalupe from North Carolina and Melanie from Worcester, Peter from Germany. You're all very welcome. So we're going to play the sponsor ads now and then we're back for the presentation shortly. Okay, see you in a couple of minutes.
Food safety accidents are a real possibility these days, meaning an increased scrutiny and rigorous testing on production and other areas. From farmlands to dining tables, each stage of the entire food supply chain is challenged by product safety, quality, and effectiveness. Whether you're a grower, food packer, trader, or hold any important role in the food supply chain, HQTS can help you to ensure quality and safety from the source. Our services include product inspections, safety audits, quality management, and consulting and training. HQTS, your partner in quality.
Okay, slides are ready. I'll be back for the Q&A afterwards, but for now, I'll hand you over to Maria.
Great. Thank you so much, Simon. Like Simon said, my name is Maria Sandoval. I'm the lab director at Trace Analytics. Today we're going to be talking about total oil analysis and compressed air. If you've heard some of my previous talks that Simon has online, we've talked about other contaminants before, and specifically from the ISO 8573 factors. In this one today, we're going to be talking about oil vapor and oil aerosol and how that's tested from ISO 8573, which is specifically about compressed air. We'll talk about methods and sources of contamination. I've been with Trace Analytics for about 5 years now. I'm a classically trained microbiologist. I've moved on to the lab director position with Trace, and I'm now working as a project leader for ISO 8573-7, which is the microbiology portion. But I do want to take a second out to talk to you guys about the importance of making sure that your facilities, your industries are being recognized in these methods. And how you do that is by logging into the ISO portal and going ahead and participating in any public comments that may be happening when you see that a certain ISO 8573 section is in rewrites. So something that is relevant for today's talk, oil vapor, or section 5 of the ISO 8573 standard, is in rewrites right now. So in a few months, we will be requesting public comments. And so again, I encourage everybody who's listening to go to ISO, log in, and get the updates so that we can hear your opinion and your needs. So let's talk a little bit about who defines and guides the industry in compressed air quality. I think right now you guys all are on this call because you know that compressed air quality matters in your field. We have regulatory bodies that range from national, like the Food and Drug Administration, to international organizations like SQF, or organizations like FSSC, or IFSI. A lot of these regulatory bodies, though, have guidelines, and that's what you can see on the right side of the table here. But a lot of those guidelines are either specifications or limits, but not all of them provide you methodologies for testing. And that is where ISO comes in. ISO is an international standard that helps you understand how to sample your compressed air for, in this case, 8 different contaminants. And today we'll be talking about oil. So 1 cubic meter of untreated compressed air contains about 200 million dirt particles. You've got water inside of there, you've got microbes, and of course you've got water. Now, right off the bat, you're probably saying, Maria, look, I don't really care. I don't have untreated compressed air. 1, I'm sure that's not always the case. And 2, it's still important for you to understand where the contamination is coming from. We need to be asking ourselves when it's time to start sampling, what contaminants do you need to worry about? What is oil vapor, oil aerosol? What is oil contamination? Where is it coming from? Is it coming from a person, like in micro, or is it coming from ambient air? What's expected of your point of use? Okay, so you're over here, you're testing your air compressor, but that's just the air receiver. That's not your points of use. So you need to be asking yourself, do each of my points of use need to be treated differently? What do I need to expect from this certain point of use? And then once you've gone through all of that, typically with your quality person, your quality person has to ask the question for your engineer or your sampler, how do we test? How do we know that the test that we are using is compliant to the specifications that we are requiring? So that's what we're going to go through in the next few slides. Sometimes you just can't reinvent the wheel. I thought this was a beautiful illustration from C.H. Reed that shows you contaminated air with all the contaminants being captured at the intake, going through filter media, pre-filtration, being captured with your filters and then being exhausted into clean air, supposedly at your points of use. So I thought this was a beautiful illustration for you guys. So the main question we have is, how does oil get into the compressed air line? Parker Hannafin has done a wonderful job with their white papers explaining a lot of this, and I encourage you guys to go on and read. But the number one culprit is ambient air, and ambient air will get you every time. And I can't express enough, even though you can't see it, it doesn't mean it's not there. We live during a pandemic right now, and so I think we're all on the same page of knowing that even if we can't see it, it's still important to test for it. And the same goes for oil vapor, contaminants, oil aerosols, things like that. So you're getting it from the ambient air, you're getting it from vehicular exhaust, you're getting it from the roads, from buildings, from expansion, tires, heat and cooling, all of that's happening around the world in the ambient air, because the ambient air is what's being taken in by your air compressor. Now, what happens after that is strictly up to you guys, filtrations, dryers, anything like that, but you got to get the air from somewhere. So I can tell you with 100% assurance, you've got some oil in your ambient air. The second place is the air compressor itself. So we're talking about lubricants, we're talking about additive oils. To make these instruments move, compress, you have to have oils. And we'll get into oil-free compressors in a little bit, but I do want to stop and say you can't run these instruments without some sort of lubricant. So keep that in the back of your mind as we're talking today. The other place is the air receiver. Okay, so you've taken in the air, you've taken in your ambient air, you've done your due diligence, so your instrument, your equipment has compressed it. Now it's got to put it somewhere. So it's going to put it in your air receiver. Well, what's happening inside your air receiver is you're having this cooling and condensation, and so you're getting this emulsions of waters and oils, particulates, and microbes, and that's all sitting inside of your air receiver. Again, it's all dependent on your filtration, your dryers, etc. But all of that is happening. And then you have distribution piping, which is my favorite conversation, because there's just so much room for things to go wrong, right? There's so much opportunity for leaks, pressure drops, point of use filtration failures. And that's where it leads us into malfunctions, separator filter malfunctions, light loading. If you're not having enough loading, what you're going to get is your instrument, your compressor's pushing too hard, and then it's excising these lubricants. You've got clogged oil return lines, fill levels. Did you overfill your compressor with oil? Is it underfilling, and is there no oil in it, and so you're getting this exhaust? So that's where we need to be mindful when we're thinking, where is this contamination coming from? The next thing we need to talk about is, what exactly is oil? According to ISO 8573, oil is defined as a mixture of hydrocarbons composed of carbons and hydrogen that are C6 and greater. So one of the things that I want to remind you guys of is, why are we talking about 8573? Well, it's because a lot of these guidelines, SQF, BRC, BCAS, GFSI, all of these are using 8573 as a guideline, or they're not giving you a method to sample for the specification that they're requiring. So then I encourage you to use 8573. But mainly, the main task of a compressor oil is to reducing typical wear and tear, right? You want to make sure your pistons are moving. You want to make sure your screws are turning. You want to make sure all of your pneumatics are working. And so that's what these lubricants are for. So you're not having this grinding. It works for cooling, sealing. And sealing is the number one thing we need to talk about when it comes to oil-free air compressors. And lastly, it talks about cleaning. And so some of you might be familiar with H1 lubricants, H2 lubricants. There's also an H3 lubricant. We're not going to talk about that today, but it is there. O-ring lubricants, seals. And lastly, before we move on, I want everyone to be very mindful of using universal oils and lubricants. It seems like a great idea until you realize that your equipment cannot function without a certain oil type. Just like your car, you're not going to put palm oil in your car. You need to put regular oil. So just be mindful of that. With the H1 lubricants, there's a little bit more of regulations because H1 lubricants are allowed to be on incidental food contact. H2 lubricants can be used in food processing, but they cannot come in contact with food. So typically, when you're using food grade air, compressed air, you're going to use an H1 lubricant if that's what you decide, and if that's what your facility requires. So let's talk about oil-free compressors for a second. Got this figure off of Parker Hannafin again, and I thought it was a really great illustration about oil-free compressors and whether or not they can guarantee your compressed air be completely free of oil contamination. And the short answer is no. So while you all gasp in horror, the answer is pretty simple. So an oil-free compressor implies that the compression of the air and the mechanics required to compress that air is a closed loop. But that closed loop is dependent on a oil lubricated seal. And so, yeah, you're absolutely right. It should be from this point on where my cursor is all the way downstream. In a perfect world, that should be relatively oil free, but anything can happen. I've already told you, oils are used for wear and tear, and you guys are not using your compressors for 2 minutes at a time. You're using them for hours, days, months, weeks, years. So, in order to guarantee that you're having this oil-free compressor work properly, you have to test. And I would recommend testing at minimum quarterly. And why is that? Well, just like the seasons, your compressor goes through seasonal changes. Even in a controlled environment, whether the seasonal change happens to be a maintenance plan, you just need to be mindful that even though it says oil free, there is still oils in your compressor that are dependent on seals, and those seals by nature are not lifetime guaranteed. They break down, they wear, and human error, they may be installed incorrectly, et cetera, et cetera. And then the next part is, okay, so your air comes down through, it goes into your air receiver, you've got some dryers, some filtration. You think you do your due diligence by doing a total oil analysis at the point of use before it branches out. Excuse me. But that is just ensuring that this system is enclosed. It's also imperative that you sample at the points of use that have direct food contact. And you can see that in order to guarantee that something is oil free, you have to test. And that may be risk based, right? If we're just blowing off cardboard down here, maybe that's not high risk. But if you're blowing breadcrumbs off of a loaf of bread, that is 100% high risk. And so you should definitely be testing. So the next thing is, okay, you now know that it's important for you to test. I have convinced you that you've got oil in your system. You're a little freaked out. You don't know how much, you don't know how little. And so the next thing that you need to do is determine your purity class. And that can be either having a baseline analysis or a diagnostic analysis, and that's telling you what you currently have. Or maybe your quality engineers have told you, no, 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 no. The filters we installed, they are a class 1 purity ISO production filter, so they must adhere to class 1. Whatever the case may be, you need to determine what that purity class is. So ISO 8573 has 6 definitions of what a total oil purity class is. And so you'll see that here in table 3. You'll see at the bottom, this is an excerpt of section 1, the 2010 edition, which is the most recent edition. I will pause and tell you this is why it's so important for public comment. This section has not been changed since 2010. So if you don't like something, I do again encourage you to do public comment so that we can see those comments. Going back, these are the 6 classes of total oil purity. Total oil is defined as the summation of liquid, aerosol, and oil vapors. Class 0, it needs to be really clear for you guys. Class 0 does not mean no oil. That's not a thing. Class 0 means that the concentration that you test for is less than class 1. So even if it's 0.008, that would be considered a class 0. Now, class 0, class 1, class 2 are required to have oil vapor and oil aerosol tests. Class 3, class 4, class X. And class X is not some nebulous number. You need to be mindful about what you think that number should be. But in this case, it is greater than class 4. This only requires oil aerosol testing. And that's because based on a lot of historical research, it has been found that oil vapors, while present in the classes 3, 4, and X, do not make a nominal difference to the final specification or the concentration. You'll see over here it'll be like 1.1, 1.001, things like that. So that is important to note here. So when you're having a specification for your points of use or your compressor, these are the purity classes for total oil. So the next question is, all right, now I know I'm a class 1. Now what do I do? Okay, well, ISO 8573 has 9 parts. 2 of those 9 parts are strictly devoted to oils. Part 2 is oil aerosol. Part 5 is oil vapor. Again, this is an illustration for you to really drill into your head that oil vapor testing can be done for purity classes 3, 4, and X, but again, they really only are detrimental to your final concentrations at 0, 1, and 2, and that's because the specification limits are so tight. So let's get into oil aerosol content. Now, it has taken me a long time to not freak out about these right side images. This is ISO 8573-2. This is the sampling setup that is offered to you as a suggestion for and normative for sampling methods. What you have here is method A. You go in, you have a ball valve. The first thing you have is pressure dew point analysis, and then you have a temperature gauge here, so the air is crossing this direction. Then you have pressure gauge here. Then you have a setup with a filter and a liquid exhaust. Now, method A is not the most common method. If you guys have liquid oil coming out of your compressor line, um, you should call your OEM immediately. That's a big deal, uh, especially if this is a point of use. So, but in either case, this is what this is showing. And then you have the flow meter telling you the flow rate at the end. Method B1 is full flow. This is what we use here at Trace. You go in your air, you got your pressure dew point, you got your temperature, your pressure, and then this is your regular bypass down here. So maybe this is what your air is going through. We have inserted a bypass up here for the filter membranes, glass membranes. The method is what this is called. You've got an exhaust for the pressure. You got a ball valve here, ball valve there. And then the most important is that you got a flow rate measurement device at the end. Part two, a little less common, is the isokinetic testing. You put an isokinetic probe into your compressor line. You again have the disc method. So B1 and B2 are very similar in that it's a disc method. And the oil aerosols and liquids are captured on these discs, whereas this is a separator system up here. So before it's time for you to sample, you're going to put in, I imagine you'll have a schematic of what you want to sample. And so let's imagine you turn on your gas source, you do your isolation valves, and you have your filtration upstream of your points of use. First thing you want to do, if you have any branches and you're doing points of use of, let's say, 1, 2, and 3, you want to purge the first branch and then the second branch and then the third branch in that order. And purging is really just getting whatever has been stuck in that pipe, getting it out. You need to have an accurate snapshot, and that's what these samplings are. They're just real-time snapshots of the contamination in your points of use. But in order to get an accurate result, you need to make sure that what you're capturing is in fact what your point of use is producing. And to do that, you need to purge what was in that pipe prior to you opening it up. So again, you want to do a cycle purge. So when it comes to measuring, so we've talked about how you're going to sample. Now you need to measure it. So this is where if you use a third-party lab, it needs to be an accredited laboratory. This is not simple analysis. You need to have quality control steps in place to ensure that the validity of your results are maintained. And I think it kind of blew my mind when I was doing some research for this webinar. You guys, only 15% of the air your compressor creates is actually used for production. 85% of it is heat exchange. The rest is loss. It just blew my mind that only 15% is actually used. So that's why it's so important, right? If you're only taking 15% of that air, you really want to make sure that it's clean and that it's up to your standards. So when you do this measurement, the labs will know, okay, you sampled using the disc method. You can do gravimetry, which is a weight differential and solvent extraction. That's what we do here at Trace. You can do gas chromatography with flame ionization detector. You can do infrared spectroscopy. All of those are options to do. The next one is oil vapor. So oil aerosol, you've captured purity classes 0 to X. Now, for oil vapor content, you need to capture 0 to 2. Again, you can do oil vapor analysis for class 3, 4, and X. It's just not something that's required. So for oil vapor content sampling, the method that is normative in section 5 is absorbent tube analysis. So they speak of a coconut charcoal absorbent tube or equivalent that you can use for this methodology. And what you do is you put it into your sampling device, and the airflow must go through it, right? And you need to be mindful of humidity influencing the results. And why is that? Well, water and charcoal matrices don't mix very well, and so you'll get a fluxed result. The other thing that is required are lab controls and field controls, or they're called field blinks, essentially. And so what that is ensuring that when you take your test, so let's say your point of use is here, your compressed air is going through here, it's going up, that you have a field blank where both ends, this is a glass or stainless steel tube, you'll have both ends broken. You need to make sure that the ambient air isn't cross-contaminating your compressed air sample. And so you'll know that because there are a number of ways to test ambient air. Typically, it's a pump that you would use. You also want a field blank to verify that the matrix was clean and devoid of any contamination when you received it. So now you know how to sample. You know the sampling method. You put it through the stream of air. Let's go back. You put your point of use here. Your compressed air is going through here at pressure. It goes up. You control the flow. You dictate how many liters of air that you capture. And then it's time to measure that. So the quantification method that's used in 8573-5 is gas chromatography. It's important to utilize solvent blanks. It talks about quality controls. You need internal controls. You need daily calibration. Here at Trace, we do full scan spectra. So we're able to use in this library of identified compounds to help you guys troubleshoot what's in your air. So 8573 tells you that you only need to quantify the contaminants. But here at Trace, it's not something it's not good enough. What good is a number if I can't tell you what might be in there? So what we do is we quantify and we identify the peaks. Now, the screenshot you see here above is a chromatogram. This is of a known standard of alkanes. But let's say in a perfect world, for whatever reason, you had some freak lubricant that had like this many alkanes in it. This is what it would look like. And we would be able to tell you based on the retention time and the concentration and the area peak, what alkane, what oil vapor, what hydrocarbon this peak is. And then we would have a solvent blank that would tell you, hey, you guys have all this contamination, but because we have quality checks in place, I want you to know it didn't come from the lab. And that can only be done if you're doing a third-party accredited laboratory, is all of these quality checks that gives you and your quality system and your facility the assurance that something didn't go wrong during the testing. You can't substitute quality control in these situations. And so that's why it's so important to make sure that when you're doing ISO 8573 testing, whether it's part 2 or part 9, you need to make sure that your reports are working for you. So what does that mean, working for you? I can't stress enough. A number is just a number, right? It doesn't mean much to you guys, and I will be honest. I know some of you are out there on this webinar who are just trying to check a box. Don't do that. Look at the power these oil reports can provide for you. Check this out. You do oil aerosol up here, you get a value. You have oil vapor, you get a value. Well, third-party testing lab, doesn't have to be us, but I wish it was. You can do identification using a NIST traceable library, identify limonene. Let's say, hey, now you know, oh man, I know the guy who came in or woman who came in to service my air compressor was spraying the point of use with some natural orange spray. That's what this is, because I have the SDS sheet that tells me, yes, there was limonene in that cleaning product, and that's what this is. I know I can tell my quality manager, hey, we need to retest. I'll tell so-and-so, maybe don't clean the point of use with this cleaning agent, and let's see if we can get rid of it. That's the power of identification, and the assurance that the identifications are verified are using the NIST traceable identified compounds. So we've talked about C6, so hydrocarbons that are C6 or greater. We've talked about oil aerosols, which oil aerosols, liquid oils, are encumbered under that oil aerosol standard. But we didn't talk about the smaller oils, the smaller hydrocarbons. And so that's where gaseous contaminants come in. So for TVHC, C1s to C5s, those are your methanes, pentanes, we can do gas chromatography FID analysis on your captured air. And in that, that's it. That's the whole package. That's your small guys, TVHC oils. That's your medium to large oil vapors, and then your higher concentrations of oil aerosols and liquid oils. And all that can be captured on a simple kit similar to this, where the compressed air comes in, it gets kicked up into the gaseous TVHC media. It goes out this way. I told you humidity and moisture will greatly drive the end result of your oil vapor analysis, because charcoals, matrices, and liquids don't mix well. So it's important to have your water testing done. You got your charcoal tube, then you have your oil aerosols on the disc method with your calibrated flow meters. All required by 8573 to make sure that you're monitoring flow rate measurements. So if you're going to do it, it's important to do it right. And so what does it mean by doing it right? Well, it means it's not just checking a box. It means that if somebody tells you, hey, we're testing our oil, here's a simple kit, it means asking the right questions. Is the sampling method, and not just the sampling method, but the sampling method and the quantifications, is that compliant? So for total oil, I've made up this quick little, let's ask myself total oil compliance. Yeah, ask yourself questions. For purity classes 0 through 2, that's oil aerosol and oil vapor, are you using a charcoal absorbent tube or equivalent? Are you using gas chromatography plus identification? Do you have blinks? Do you have solvent blinks? Is your detection limit 0.1 micrograms to 0.5 micrograms? Do you have flow measurement? That's required. Did you meet the minimum and maximum detection limit? Are you meeting the appropriate sampling times? Are you using the sampling disc? Are you meeting the flow rate measurement accuracy requirement of 5%? Testing is not easy, but it's mandatory. And when you use a distributor and a third-party laboratory, it can be done in a way that can help you guys save money, save in costs, because yeah, it's a simple setup, but the analysis has so much power to save you guys money, and just headaches worth of complications. Especially, I told you you're only using like 15% of the production of your air compressor. So let's make sure that that 15% being tested is in fact compliant. So in summary today, what did we learn? We learned that oil contaminants can originate from several areas along your compressor system. We know that risk assessments will dictate your purity class. And I can't stress that enough. Not every point of use has to be tested. I mean, it just doesn't. But the ones that do need to be tested, they need to be done accurately. They need to be done correctly, and they need to be done in compliance to the specification. And that does require a little bit of legwork on your part, asking those tough questions. These questions are not easy for laboratories to answer, but they are if they're compliant to 8573. So I do encourage you, if you want, take a screenshot of this and ask your laboratories if, or your tester or your distributor, hey, are my reports, are they coming in compliant? Because it matters. And lastly, again, just making sure that your sampling method and your measurements meet the specification. And with that, I'll take any questions that you guys have. I left some room for us to have questions because this is not the easiest topic. And I want you guys to have the freedom to ask me anything that you have on your mind regarding oil.
Okay, thanks very much, Maria. So close the slides. There aren't many questions. I might say there aren't any questions actually so far. I don't know if that's a good thing or what. Yeah, so if anybody does have a question, please, while we've got Maria here, do put it in the sidebar and we'll gladly get an answer. I mean, if you can't think of one at the moment and one comes up, Trace and Maria are always there to help via email as well, which we have done before.
Yeah, absolutely. I mean, and I can't stress enough that it really blew my mind that the statistics out there, like 15% of air production is all that is being used. So it seems wildly important that you guys in the food industry are sampling correctly and you're testing correctly. Like Simon said, if you guys have any questions, do feel free to email me. I had my email on the screen, but it's also maria@airchecklab.com. If you have any questions.
There are one or two now. So Angela, can you talk a little bit about the test kit and how do we send that back to the lab for analyzing?
Yeah, so the test kit is a simple stainless steel kit, essentially very easy to clean if you need to clean in between your points of use. And the sampling media is individualized per point of use. If you use our kit, you just put those pieces of media back into the box, secure it with, making sure there's netting around it so it doesn't get banged up during shipment. But you ship it back to us, and the laboratory takes it from there.
Okay. Another question from Emma. When you have a third party test your air, do they take the samples or do we and then send them in?
Yeah, so that's a very good point. It depends. So typically, what we see here at Trace Analytics is a little bit of all of the above. We have individual people from the food industry taking their own samples. And here at Trace, we offer training courses and a training certificate. So it's called the Air Check Academy. So you can give your quality manager your training certificate that says you've been trained to use the kit and take the samples, which is incredibly important for SQF and GFSI compliance. But as well, if you use a distributor, the distributor can also take this online course. And then what they do is they provide you the final report. So they work with you to set up a time to go test. They work with you to set up the testing schematic, which points of use, when you're going to test, how often you have to test. And the laboratory will then either send you or your distributor a reminder based on your testing schedule. So if you're quarterly, we'll ping you every quarter to tell you, hey, Emma, your test is due. Please give us a call. It's time for you to sample. Or it'll ping your distributor and say, hey, Emma's distributor, it's time for you guys to go test Emma's air. And that's the upside of having a third party laboratory help you out there, is you don't have to remember. You let us do that.
Okay. Question from Michael. What are the best practices in the maintenance of air service units where moisture is always a contaminant?
Yeah, so if moisture is always a contaminant, then you need to ask yourself whether or not, and I'm going to speak first on oil testing, and then I'll speak on moisture. But if you have to test for total oil and you know that your air compressor is generating wet air, you need to be mindful that using charcoal, it requires a 75. It requires that you meet no more than 75% of the humidity present in your air, and that is part of the specification. If you don't meet that, then you can't adhere to 8573. And then, if that is true, that's fine. That is more than fine. What that means is you need to call a third-party lab to set up a custom specification, and then we will ask you, what specs do you want to meet? What limits do you want to meet? And then the laboratory can test to that. 8573 is just a guideline. It's not a, stick in the mud saying you can't do anything else, especially if you know you have a lot of moisture in your air. Now, when it comes to maintenance of these units, if you have so much moisture in your air that it's draining out of your drain, the drain exhaust, I would definitely recommend calling your OEM, especially if you're in food and especially if this is direct contact. If it's not, then again, it may not be applicable for you to do oil vapor. You may only need to do oil aerosol. So those are the questions worth asking when you're having moisture issues and you need to test for oil.
Okay. Did Trace extend to the UK? Question from Yoga. Where in the UK compressed air be tested?
Yeah. Trace Analytics is very unique in that we are an international compressed air testing lab. We're also HACP certified. So if you give us a call, we can set you up with a kit and we can get it out to you by the beginning of next week if you wanted to. But yes, absolutely, we service not just the United Kingdom, we service Asia as well, Eastern Europe, Africa. I haven't gotten Antarctica, so if you're on here, Antarctica, call me.
They probably are, Question from Cara. What are the appropriate limits for oil in air? What triggers a need for corrective action? You may have said when discussing each purity class, but would appreciate the clarification.
Sure. So what are the appropriate limits for oil and air? That sadly I have to kick back to you. And Simon's heard my spiels 100 times already. It feels like it feels like an excuse when I tell you, well, I can't really tell you that. But it is a risk assessment that your quality department has to provide for that particular point of use for you to determine what the appropriate limit of oil is in that air. Now, there are plenty of specs, like the FDA has no more than 10 parts per million of a certain amount of oils in foods that have direct contact with ambient air. So you could deduce some limits there. You could deduce some specifications there. What triggers the corrective action? I really wish nothing triggered a corrective action. CAPAs are super useful for your facility, but they can be daunting when you don't know what is triggering it. So the simple answer for oil analysis is if you are beyond the specification limit for the purity class that you are testing for, then you should open a CAPA. Now, I will say you should have alert and alarm limits in place as well. So if you're a purity class 1 and your limit is 0.01, you should have an alert limit that is just above that. And you should have an alarm limit that's just above that. So that way you are monitoring and you're not caught unaware when it's time for you to test.
Okay. Question from Cara. Many companies I've worked with have only performed microbial testing on compressed air, not oil. Is oil in air a larger concern for product quality, taste and smell, for example, or can it be potent enough to cause a food safety concern?
Absolutely. Absolutely 100%. You ever sit inside of a brand new car and take a deep breath? That new car smell, those are hydrocarbons. Those are plastics. Exactly like if you ever walk through a forest after rain, that fresh air smell, that's bacteria and mold. So smells are a huge indicator of contaminants. Now, I like the smell of roses. I'm not going to say that's a contaminant. But if you're smelling your end product of your point of use and it smells like anything, yes, you need to be testing. It's also important to remember a lot of these. So you ask a micro question to a microbiologist, I got to be careful. I don't go down a rabbit hole. It's important to note that there are microbes that can produce extracellular proteins and secondary metabolite molecules that are hydrocarbons. And so some of those smells, yes, you need to test for micro. Yes, you also need to test for oil. And I can't stress enough, these O-rings that are lubricated, they're meant to wear down. They're not lifetime O-rings. So you need to be mindful of the wear and tear on your instrument, not just for microbiology.
Okay. Laxmikan, yes, we will be sharing the presentation afterwards. We always follow up with the recording and the slides, so you can rewatch it and have the slides to reference. And also, if you need to contact Trace, the contact details are within the slides as well. So, yeah. Any further questions then?
There is one here that I see from Bernard. It says, is there a big difference between air for anesthesia and air in contact with food?
Oh, right.
And the answer is absolutely. Breathing air has very strict requirements, but it's also very important to note that the sampling of breathing air can be the same as ISO 8573. So if you are using breathing air, and he mentioned anesthesia, your limits will be X, Y, and Z, but you can still use the method guidelines from 8573 if the specification in breathing air that you're required to hit does not require an alternative method. But yes, contact with food is very different.
Okay, a question from Angela. Is particle testing included in the test kit?
Yes, particle testing is included. It's well, here at Trace Analytics, we do a double whammy. Two birds, one stone. We do analogies all day. You get oil aerosols and microscopy analysis, which will tell you particulates. You can also do LPC analysis. And we've had a customer before daisy chain a laser particle counter to the back end of our, it's called a K810, to the back end of our K810 kit to do very stringent particulate counts. But yes, you absolutely can do particle testing. You can do all of the testing: particles, water, oil, microorganisms, using the K810 and a funnel.
Okay, super. Let's have a look. Question for Marenga. What's the quantity of air to be sampled to analyze?
So that's a really good question. Sometimes I don't mention it because it can be scary. When we look at method, so if you'll remember, think back to the slide where I told you for oil aerosol, there's method 1, method A, method B1, method B2. So for method A, the sampling can be up to 400 hours. That's wild. How long is that? For sample B1 and B2, those are more approachable. That's 10 minutes to 100 hours of sampling time. And when you're talking about time, you can also talk about air volume. So that can be anywhere between 40 liters of air to 4,000 liters of air. It's very important that laboratories acknowledge that air volume directly impacts the limit of quantitation for the measurement. So the more air you sample, the lower the limit of quantitation will be. So when you're thinking about picking a laboratory, just be mindful that sometimes extrapolating results doesn't adhere to the standard. So just be mindful of that.
Okay, I think we've cleared them all. So yeah, perfect, really, because it's 1 minute to go. So lovely. So yeah, thanks very much for your time today, Maria.
Of course. Thank you.
Keep cool. And enjoy your weekend. And
you too. Thank you, guys.
We'll see you soon. Thanks, Maria.
Bye-bye.
Okay, Maria Sandoval from Trace Analytics, who are one of our kind sponsors of Food Safety Fridays and the IFSQM website. So it's always great to have them along. We will be following up with the slides and recording in an hour or so. Your certificate's in the sidebar if you want to grab that now, although we will issue that later with the recording as well. Yeah, you have to sign your own name on the certificate, so print and sign or edit it in an image editing software and type your name. So thanks for attending today and engaging with the webinar, and we'll see you on the next one. Have a great weekend. Take care, everyone. Bye.